Hello, this is section 1.3, grade 10 math. We're looking at ways of describing data. The first section, we're going to look at measures of central tendency. Now, that's a big term, but it's important that you realize what they're talking about. They're looking at the different types of averages. Three types are mean, median, and mode. Mean's the one that you know of when you talk about finding the average of your test scores, and what we do is we add up all of the numbers, all the values, and we divide by how many values there are. Now this can be represented in a neat little mathematical equation. This is the symbol for mean. So you see that bar on top. You see that right here. This symbol just means the sum of all values, and then this bottom one is the number of values. So you've all done a great job at finding mean in the past, and so I'm just going to move on to the example. For mean, you add up all the numbers and you divide by the number of items. So in this case, all of these are your numbers. When you add them up, this is what you get. There are 1, 2, 3, 4, 5, 6 of them, so you divide by 6, and the mean is 16. Median is the middle value or the midpoint of a set of numbers, and sometimes it's best to use median, and we'll see a little bit later when you use mean, median, and mode. So the key to this is to finding the median is arranging the numbers from least to greatest. Now, if we just look for the middle number without putting them in order, we would say, okay, 1, 1, 2, 2, then 23 must be the median, but it's not. You have to put them in order, and then you can 1, 1, 2, 2, and find that the median is 20. Let's next take a look at what happens if there's no middle number per se. In other words, if we went 1, 1, 2, 2, oh, what do? There's the middle. So we have to find the mean. In other words, we have to take a look at the two numbers beside the middle, and we have to add them together, divide by 2, and we find in this case that the median is 21. So there's two examples of find median. Very simple process as long as you put everything in order from least to greatest. That's the key. Mode is the final one. It's the number that appears most often in a set of data. Very easy to find. It says you put them in order, and that but really, you could take a look at a set of data and you could say, gee, what is the mode? Well, it's the one that appears most often. 26 is there twice. All the other digits are only there once. Could you have more than one mode? Certainly could. If 20 was there, again, then 20 would also be there twice. So then the mode would be 20 and 26. Okay, one of the things we want to take a look at is outliers. And outliers are numbers that sort of fall far away from the normal number that you see. So for example, in our class, if we had a test and most students made between 70 and 80, but there was one student that made 99 and there was one student that only made 26. Those are the outliers, the 99 and the 26. And they really affect our data. Just think if we had 2 or 3 students that had missed a lot of time and all 3 of them made 26 or below. That would really skew our averages. So we always have to be aware of that. So in this case, look, these numbers sort of appear to be very similar, but in fact, they are all between 3.2 and 6.6, except for 10.7. It's really quite a bit out of the range. So if that's the case, it's considered an outlier. Here's another example. This case, Moore's Law. This deals with computers and computer capacity over the years. And we know that computers keep getting faster, they keep getting better, everything keeps increasing, and Moore's Law represents that. And but there's a few that are a little bit off the line, and then look at this one, the Atom processor. It's quite a long ways off the line. It's an outlier. Anybody that's bought a netbook probably has an Atom processor in it. And it just shows that it's really quite a bit away from the fastest computers at this time. Range is another term you need to know. It's simply a matter of taking the largest and the smallest number and subtracting. So in this group of numbers, the largest is 10, the smallest is 6. So we would say the range is 4. Flipping ahead a little bit, let's take a look at where we would use mean, median, and mode, because one is usually better than the other depending on the situation. And we have to be pretty careful in choosing which is best so we get accurate information. Now, mean is best when there is very little difference between the highest and the lowest value. So here's an example where we have a gas station, and the prices, look, you can drive around town and the prices really aren't very much different for gas depending on what station. So in that case, mean is best. Also, there's no outliers here, and that's pretty significant when it comes to looking at mean. So all within the same range, or a very small range, and no outliers. That's when mean is the best. Median is the best when things are clustered closely together, but there can be outliers. It's okay to have an outlier for mean. So in this example where we have 4 houses, they're all in the same neighborhood, they're all the same type of house, but most of them sold for around 149 to 155. Well, 180 was the 4th house. That's $30,000 difference approximately from the other houses. So it's certainly an outlier, because $30,000 difference to me, that's a lot of money. So outliers are okay for median. Now, we look at data in different ways, and mean and median are generally appropriate for continuous, what we call continuous data, and I'm going to show you what that is in a minute. Just going to scroll down here. If we had a taxi ride, taxis charge us by the kilometer, and they even charge us for a portion of a kilometer. So in this case, if it's 40 cents a kilometer, we travel a certain number of kilometers, and we can just chart out our price. For example, if we went 15 kilometers, we could go up to our graph, and we could say that it's about $6.75 approximately. So we could go anywhere along this line, and we could come up with a value for a taxi ride. So continuous data, very important to remember that the points on the graph are joined, and you can look to any point to get data. Now, the opposite to continuous data is discrete data. And I don't know if you realize that when you make a phone call using your cell phone, it doesn't matter if you only talk for 20 seconds, they charge you for a minute. If you talk for a minute and 5 seconds, they charge you for 2 minutes. So they always round it up to the nearest minute. So in this case, if you talk 10 minutes, it's $4. Talk 20 minutes, it's $8. It's not just anywhere on the line. It's just and that's why we represent this graph with just markings as such. We don't fill in between. So that's discrete data. Now, should I use mean or median? And here's the situation. You're in a hospital. How long do you stay? Most people only stay overnight. They try to push you out of the hospital as quick as they can. They don't want you there getting germs. They don't want to fill up a bed that they may need. So they try to get you moving. But you know, we have somebody in our school that probably was in the hospital for 365 days. So that really throws off our results. It skews our results. So we would have to choose, hey, what do we use, mean or median? Now remember, if you have outliers, and that 365-day hospital stay is an outlier, then you're going to choose median. Okay, so there's a good example for you. I want to move right along. When is mode the best? Mode is best when you only have discrete data. So let me give you another example of discrete data. If we were looking at the number of children in a family, we could say that some families have 1 child, 2 children, 3 children, and so on. We couldn't represent that. We couldn't say, I'm going to find the average, and the average is 1.7 children. You can't have 0.7 of a child. It has to be a full child or a second child. It can't be in between. So that's where we use mode, when there's things like that have to be a full amount. Now, shoe size, usually shoes, I know they go by half sizes, but you can't have size 9.3 or 9.9. So that would be an example where discrete data has to be used. It could also be used for specific things like race or sex. If you had male or female, you can't have something somewhere in between. So we can say that mode's rarely used in real life, but in fact it works very well for things that have fixed amounts. Okay, here's a few review questions for you. I like the first couple the best. You have to choose mean, median, and mode, and both 1 and 2 look almost the same. It's the height of basketball players. One of them is the Fredericton High School boys basketball team, and the other is the Grand Manan Community School team. Fredericton High School, huge school, 1,000 students to draw from. I bet that they pick mostly the kids that are very, very tall, that have great basketball skills. The Grand Manan Community School team, they're also looking for great players, but they only have about 40 students to choose from. So they probably have a variety of both tall students and short students and lots in between. So in this case, the Fredericton High, number 1, we would choose mean, because there are no outliers and the values are all grouped pretty much in a very small range. On the other hand, the Grand Manan Community School team, where there's tall students, medium students, and short students, there could be some real outliers there. You could have a couple really tall kids, but you could also have a couple really short kids. So the chances of that happening are great, and so the fact that there could be outliers would be your choice for median. Okay, I'm going to stop there. That was a pretty quick review of what we've been doing. If you have any questions, I have also bookmarked some sites on our webpage that you can go to, and of course you can always get after school help. Good luck.